Next, let's specify the governing equation, boundary conditions, and initial condition for each area. So that'll specify the mathematical model. Let's start with the sand mold. So the governing equation for transient 2D conduction, when we have chosen, so if I go to Workbench, since we chose transient thermal, by default, it'll solve this equation, and we need to give it K, rho, and Cp for sand. And that you would do by coming into Workbench, double-clicking on engineering data, and then adding, say, your material, and then you drag density, isotropic thermal conductivity, and specific heat. And so once you give those inputs, now you also have to assign it. So let me give some dummy values here. The actual values are in the problem statement. And then I can either say refresh here, or I can go to mechanical and say file, refresh all data. And if I go and look at materials for sand, I have those values, and now I need to assign it over here, which is very easy to forget. So at this point, ANSYS will knows that that's the governing equation it needs to solve in the sand region. And if and then what about the region where the casting is, where we have to get it to switch to the enthalpy formulation on the right hand side, and we do that through the material properties. So for the casting, you would go back to engineering data, and you would add a new material. And if I go here, okay, I need to specify K, the coefficient of thermal conductivity. So I'll again drag that and give the appropriate value. And now instead of density and specific heat, we'll actually specify enthalpy versus temperature. So I'll drag that, and you see I have to give it a table, and I can start typing in the values. So if I go to my slides, I start off with 25, which is the reference. Usually this should be 0. ANSYS doesn't like 0, so that's why I used 1. So I'll say 25, 1, and then for 655, which is the which I'm assuming to be the solidus temperature. So I'll say 655, and then I'll give it the appropriate value, 1.53 e to the power of 9. And you can check the units, and then you would type in the rest of it. And again, you need to refresh. So let me just put in a dummy value here. And again, I would go into mechanical. I would say refresh all data, check that the values are right. So I can it'll plot that. When you do it right, you should see something like this. And then, so at this point, and then I need to also assign it. So I'll assign the material. That's a casting material. So at this point, because I assigned enthalpy versus temperature, ANSYS is like, oh, I know you want to solve this version of the governing equations. So that should complete the specification of the governing equations. And if I pop over to my completed demo, let's see. If I go to the completed one, and you will see that, for the material, for sand, I have the right values of these 3 parameters, and then I called it aluminum for enthalpy approach. I've also tried the CP approach. These 2 should give me the same result below the solidus temperature. So if I look at this, I can now make sure that I have the right variation, and then I have also assigned it. So that's what it'll look like when you've do all the inputs correctly. And then the next thing is, so at this point, the governing equations should be specified. And the next thing would be the boundary conditions. And so if we start with the sand, we are setting a temperature of 20 degrees at the left end. So you would go to, you would say transient thermal, temperature boundary condition on the left boundary, and you would give it the right value, which is 20. So, and then insulated is the default, so nothing to do at the other boundaries. And then for the initial condition, you have to do it through commands. So I'll show you how it's implemented in my completed demo. So you would have to insert a command, which you do under transient thermal commands, and then it would, and I'll give you a demo of this. You need to make sure you're in the right units, and then you need to specify the initial condition through the commands. So if I look at the command, I see IC is initial condition. That's the command that ANSYS has for setting the initial condition. This says that, for the entity called casting, set the initial temperature. So this is the variable temperature to 700. So how do we give the name? How do we say what is casting? That's through named selection. So I created a name selection called casting, which corresponds to this. So between creating the name selection and having this command, it's setting the initial temperature for that region to be 700. So let me show you in a little bit more about the implementation. So you would come here, transient thermal, you would add commands. You can rename this, which I won't do in the interest of time. Make sure you're in the right units. We'll just do metric, and then you type in the command, which I've provided on the in my PDF. Here I'll be lazy and just copy it over. So you'll just type it in like that. And but I need to tell it what casting is, and here I already have added it, so let me delete that. So the way you would do it is you would go into, you'd say highlight geometry. You want to apply the name selection to an area, so I'll select the area, and I will right click and say create name selection. And then I would call it casting. And so that has the name selection, and now it knows that, hey, for that region, set the initial temperature to 700. And you need to do the similar thing for the mold. So if I go to my completed demo, I have the same thing repeated for the mold, where the initial temperature is 20 degrees Celsius, and I added a name selection corresponding to the mold. So that with that, ANSYS should have the governing equations, the boundary conditions, and the initial condition. You can save the project.